and today I am going to go over correlations, and I'm going to show you an example of a correlation matrix. Adjust my microphone, hopefully, yep. So I'm just going to full screen this, and we will get through this. So the correlation is a mutual relationship between or a connection between two or more things. It's like, as you know, I've been going around talking in class, both online and offline, about the correlation between ice cream cells and temperature. An example of a correlation is that relationship, the ice cream and temperature relationship. And the way you could say this would be, as temperature increases, ice cream cells also increase. That would be a positive relationship. If it were an example of a negative relationship would be, as temperature decreases, coffee cells increase. So, the colder it gets, the more coffee cells. Could also, say the earlier in the day, so like, earlier in time, so time goes down, coffee cells go up. So, in other words, there's more coffee cells that occur around 8 a.m., 9 a.m., etc. And so, that being said, 1 second. So that being said, that's kind of the example of a positive and a negative relationship. It's just the correlation between those two variables. So, positive is they both go in the same direction. Negative is they both go in and they go in different directions, and I'll cover that in more detail as we go through. So these correlations are expressed in correlation matrices, and I will show an example of the correlation process, including making a matrix, correlation matrix. The correlation matrix gives a quick and easy read about the correlations in the data set. Again, I'll show you an example of those tables. These tables are often in professional research articles, and most people tend to like the correlation method. Matter of fact, correlations are probably the most common bivariate statistical presentation, and generally they're always used if the data is interval ratio. So, took a drink of my coffee there, and let's move forward. Correlation matrices are a table that shows the relationship between all possible pairs of variables. I'm sure I didn't skip through. This is bivariate, as I explained, and these correlations pairing may suggest leads for further analysis. Remember, bivariate testing is just kind of like diagnostics. Bivariate testing is diagnostics. And as always, correlations do not imply causation. If they're simply diagnostic tools, and it can be used to test if the research is worth the time or not. So, if you don't get any correlations, you get weak correlations, you get no p-values on those bivariate statistics, odds are you either need to sample better, or you could probably just move on. Like, for example, the final projects that are in the class, it's going to be a case of you need more sample when you get your low p-value, when you get your high p-values. So correlation numbers, they have the input range, they have a range of -1 to 1, with -1 being perfect negative correlation. In other words, a complete down no matter what. So, and I'll move forward that, and a 1 being a perfect positive correlation. Positive correlation means that high scores on one are associated with high scores on the other, and that low scores on the one are associated with low scores on the other. And in other words, they do move in the same direction. So let's say, the ice cream cells and temperature, they move in the same direction because temperature goes up. When temperature goes up, ice cream cells go up. So they're both moving in the same direction. Coffee and temperature goes down, but coffee goes up. They're moving in opposite directions. So, and then, negative correlations, as I said, means that high scores on the first thing are associated with low scores on the second. Negative correlation also means that low scores on the first are associated with high scores on the second. Do not get too confused about negative correlation. No matter what order you list them in, it's still the same sentence. You can say, as coffee sales increase, temperature will decrease. You could also say, as temperature decreases, coffee sales increases. It literally doesn't matter what order you put them in, it's still the same relationship. Same with the positive correlation. So your coefficients vary between 0 and 1. Remember that's also in the negatives. The closer correlation goes to 1, the stronger relationship between the two variables. Think about this as a percentage. So 1 being 100% correlation, and 0 being 0% correlation, and all the stuff in between being that, including negatives. So like if you got a negative 0.1 correlation, it's a negative 10% explanation of variation. So a correlation of 0 indicates that absence of a relationship. If the correlation coefficient is negative 8, negative 0.8, which indicates the presence of a strong relationship. So you're going to talk about this a bit more in detail, of course. Positive correlation coefficient means that as variable 1 increases, variable 2 increases, and conversely, as variable 1 decreases, variable 2 decreases. In other words, the variables move in the same direction when there is a positive correlation. And a negative correlation means as variable 1 increases, variable 2 decreases, and vice versa. So, as you know, talking about those two examples I showed you, and I'll do another example in the Excel sheet when I do the Excel sheet to try to to get some variation in the examples. So for statistical significance, its p-value less than 0.05. This means that the probability of obtaining such a correlation coefficient by chance is less than 5 times out of 100. So the results indicates the presence of a relationship. So for negative 0.8, the statistical negative relationship between class size and reading score, such as the probability of this correlation occurring by chance is less than 1 time out of 1,000. In order to obtain your p-value for your correlations, you need to either perform chi-square or you need to perform ANOVA. So just you'll have to perform. The best way to do it is through chi-square though. So get that chi-square. The effect size for correlation is called the coefficient determination. It's defined as r squared. The coefficient determination can vary from negative 1 to 1 and indicates that the proportion of variations in the scores can be predicted from the relationship between the two variables. An r squared between 0 and 1 indicates the extent to which the dependent variables is predictable. An r squared of 0.1 means that 10% of the variance in y is predictable from x. An r squared 2.2 means that 20% is predictable, and so on. So I'll go over this again. So let's say you have a r squared of 0.1. That means that it's 10% can be explained in the change between each other. So in other words, I'll go back to the ice cream sales. Ice cream sales, let's say we have a correlation r square of 0.5 for ice cream sales and temperature. That means that 50% of the variance in ice cream sales increase can be explained by the temperature increase. So in other words, say this again, 50% of our ice cream sales are influenced by the temperature. Because during the summer months it gets hotter, people want more ice cream. That's what that's saying. And there's 50% other factors that are going into there. So we could say like age of the person buying it, for example. Don't have to worry too much about this, but this is the r squared coefficient determination formula, where r squared equals, and I'll go over this, 1 divided by the number of observations used to fit the bottle times sigma, and then you got a multiplication, where it's that x of I is x value of observation, x is the mean value times y sub I, which is the value for observation I, y is the mean value, and omega x times omega y is standard deviation. It is the standard deviation of y and x, and then you square. Don't have to worry too much about that. I'm just showing you the formula to show it to you, and we will move forward. So let's look at examples. What does this tell us? Starting upper left of the table, birth rate infant mortality equal 0.88. This means that infant mortality increases if birth rate increases. This is a strong association. Notice how this is mirrored. And I'll take my mouse and run through. See how it says is 1, 1, 1, 1. And the way you read this, you take the first thing you're interested in, so let's say birth rate. And then we move across until we find the other thing we're interested in. So like if we're interested in birth rates comparison to birth rates, it's a 1 because it's measuring the same thing. In other words, 100% of birth rate is variation is explained by birth rate. Well, that makes sense because, we're talking, oh, hey, how fast I run is explained by how fast I run. It's a pretty simple statement. So, Captain Obvious here. Now, let's move on to comparisons between two things. So, let's say birth rate and infant mortality rate. Another obvious thing, but we're just moving forward. Birth rate. So, let's infant mortality rate. What we're interested in infant mortality. What causes infant mortality rate? And we see it's got an association of 0.88 with birth rate. See how right there, that little movement there? In other words, in areas with higher birth rates, we will start to see higher infant mortality rates. 88% of the variation in infant mortality rate is explained by areas with high birth rates. In other words, high birth rates have a big fat role in that. Moving on, infant mortality rate, life expectancy. Okay? In areas that have high infant mortality rate, we can see a very large decrease in life expectancy. That makes sense, right? If babies die during birth, it does count. That produces a death certificate. So life expectancy should go down as a result. That's 89% of the variation. Again, infant mortality rate and percent urban, it's a negative value. So what we're saying here is infant mortality rate increases, percent urban decreases, or we could say the other way around, as percent urban increases, infant mortality rate goes down. So let's read it from the percent urban side. So let's go here. The higher, the more urban an area is, we can see life expectancy go up, we can see infant mortality rate go down, and we can see birth rate also go down. So hopefully that helps with the visualization, and I'll make one of my own. Here's a correlation in Excel. You can look at it through the YouTube video here. I'll show it to you on this YouTube video as well. Or you can do it via the data analysis toolpack option, and I'm going to show you that example now. So let me pull up Excel. Now I'm just going to quickly make a data sheet very quickly, and we're going to do. Zoom this in, and we're going to do. We're going to do a data analysis. So let's see what's the relationship is pretty simple. Today the relationship is pretty simple. We will go with having a morning block here. I'm going to go with so let's go to child abuse statistics, okay? So child abuse cases in an area. Okay. And we're also going to go with poverty index. And we're also going to go with average age of couples. No. Average age of caretakers. So that way we can, if it's like only one caretaker, we can say 23. Oops. If it's only one caretaker, we can say 23. My goodness. We'll say that. And if it's two caretakers, we could say, equal 23 divided by plus 25 divided by 2. Maybe. That is not right. Ugh. Yeah, so. something's up here, and like I said, it's early morning, so forgive me. And we're just going to do something real quick. Yeah, I know what I did wrong. Still not working. You know what? We're just going to go with average age of caretakers. We're not going to do math, but you know, 23 plus 25 divided by 2. And for whatever, I can't get the formula to work unless I do multiple cells, so I'm not going to prank with it this morning. So, average age of caretakers, poverty index, child abuse is an area, and we'll do one more. We'll do a relevant correlation. A bird just flew by, birds in area. Okay, so our unit of measurements will be geographical areas instead of people this time. So we'll say, well, we will do Louisville, and we're going to do area 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 7. Copied it on my mouse. And we're actually going to even like put more detail on that. And we're going to say area name. And we'll go with Beachmont. And this is just going to be completely random data. I'm not associating anything with anything. I'm just like, you know, putting in random data. Beachmont, Crescent Hill, J-Town, Shawnee Park, Cherokee Park, Iroquois. How do you spell Iroquois? Oh my goodness. That is not how you do it. You know, I'm going to go with that. What's the other ones? We'll say downtown, uptown, uptown, and one more. And we will say Fairfield. I know. So, all right, child abuse is an area. Like I said, I'm not going to associate anything with the stats, but I am going to make these make sense. So. We have, and we'll assume that all this data was taken only in the year 2020. So we got 123 cases here, 152 cases here, 102 cases here. Oops. And we got 55 here. We got 321 here, 150 here. Downtown, 375. Butchertown, 180, Smoketown, 67, and finally Fairdale with the lowest. Alright, so we got Shawnee Park, our low variables are Shawnee Park and Smoketown, and then Fairdale. So now let's go with the poverty index, and we're going to make this make sense. Okay? So we're going to say poverty index of on a scale of, well, I'll get this with the coding, okay? So we'll go data. Notice that I'm going down in my tab down here. Data and codebook. So we're going to do a 1 through 10 scale on poverty, with 10 being the most impoverished and 1 being the least impoverished. And we're going to make this make real good sense. Now we can just put some variance in between everything so it can pick out, you know, there we go. Average age caretakers. We're gonna make this make sense too. Make this make all the sense. There we go. And then birds in area. We're going to have almost no relationship with this, so we're just going to put in, you know, random bird data and keep it around the same number. That way, you know, we don't really see a whole lot of relationships occurring. So here is our simple 10 sample data set that we can do a correlation matrix on. So how do we do a correlation matrix? Well, we're just going to go down here and we're going to type in all the variables. Okay, starting with area, starting with child abuse as an area. And I'm just going to go down and say poverty index, age, I'm going to say age, and then finally birds. Okay. So there is our first, and we're just going to hit equal, transpose, and highlight this. Enter. There we go. And now we know for, I'm just going to do this. So equal, this is how you start doing correlations. Equal, coral. So it returns correlation coefficient between two data sets. Oh my goodness. Okay. You should be able to say this too. So equal coral. And then we just go with child abuses in area compared to child abuses in the area. So highlight the first one, hit comma, and then highlight the second one. In this case, it's the same thing, so we get a return of 1. Now what we're going to do is equal coral, and this is poverty index, and child abuse. And we get a return of a very high 0.93 correlation. Equal coral. This will be a negative correlation. This is child abuse as an area. Well, this is age. It does not matter the order you put them in for the record, but I'm just being a little bit more, I'm being organized here. So put in age, comma, child abuse as an area. Enter. And then this should be a no relationship because I intentionally did a no relationship. Child abuse is an area. So birds first, comma, child abuse is an area. Well, it's actually got some part of this correlation, but it's a very weak one. So, you know, I tried. Alright, so now we'll just go ahead and fill in the ones real quick. Because, you know, poverty index, poverty index, poverty index, poverty index. No, you know, it's going to form a diagonal of ones. It's going to do. And then birds in the area and birds in the area. All right, so now we're going to do the same thing. Poverty, child abuse is in the area. The poverty, which we've already done if you notice. And you'll start to see a pattern here. It starts forming a mirror image. And so, you know, with the ones, one other, so poverty index, child abuse, poverty index, child abuse. We'll get age and child abuse right here in the mirror image. So, you know, that should be at -6 age. And then child abuse. I had a brain fart there. And then finally, our birds and our child abuse. So birds, child abuse. So we have that. Now let's just, you know, kind of fill in the rest. They do follow a mirror pattern. I'll show you that. So this is age and poverty. So age Again, it does not matter the order as long as you just have that comma that separates them, age and poverty. This will be a new correlation. Yep, and it says right here, as age decreases, poverty will also go increase, or as poverty increases, age decreases. Or as poverty decreases, age increases. It's the same thing. One says as you get younger, you get poorer, and the other says as you get older, you get richer. Well, never mind. Yeah, as age increases, your poverty decreases. Yeah. So, yeah. It's just a different way of saying it. And then we got birds equal coral and age. Let's go up here. We're going to do poverty and age index again. Get that? It'll be at negative 0.77. We've already done that one, but it will be a mirror image. Get that mirror image in there. And then we'll do birds and poverty. Do birds cause poverty? Now keep in mind this is a low sample size, but it's a pretty weak one. Birds and poverty again. This is the mirror image of over yonder that we just did. So birds, poverty. And finally the last is age and birds. Average age and birds. Now the birds row is going to be nonsense because it's just talking about and then general weaker relationships. Also, as you can see, weaker relationships. So this is our correlation matrix that we just made. So we're just going to highlight it a little bit. There we go. And so here is the whole correlation index. And again, use equal coral, highlight, equal coral, highlight, equal coral, and highlight the ones. Make sure you have your comma in. Anyway, as you can see here, the mirror images are there. 0.93, 0.93, negative 0.66, negative 0.66, 0.34, 0.34. Negative 6.6, negative 6.6. And images, as it goes forward. And wait, because it's birds and child abuse, right? Birds, child abuse, negative 3.4. Child abuse, birds. So in other words, you could just, if you wanted to, and a lot of people do this, present your correlation matrix like this. Because this just doesn't matter, that part, because the answers are here already. So there's your correlation matrix. And it's less noisy when you present it this way. So how do we get p-values for this? Well, we got the code, unfortunately. So let's get to coding. Now we're going to code in a way so we don't have to worry about these two when we're coding. We just got to worry about the items that we made correlations for. So let's go ahead and copy this over. Make our code book. Zoom this in. So child abuse is an area. What we're going to do is code it as either low, medium, or high. Simple coding, okay? Whereas 1 equal low, 2 equal medium, and 3 equal high. Pretty simple stuff. Poverty index, we're just going to do the same drill. It is 1 through 3 equal low, 4 through 6 equal medium, and then we're going to go 7 through 10 equal high. Average age of caretakers, we I'm going to run a min and max of caretakers, and let's see, so equal, we got to figure out what our parameters are, so equal minimum, highlight that. We got a minimum of 19, equal maximum 32. So we're at a range of 19 through 32, and we're going to say 19, 0 through 21 equal young, 22 to 26 equal young adult. No, not young adult. We'll say adult. We'll say young adult. And then 27 through 99. Older adult. I'm just making it simple with 3 categories. That's all I'm doing here. So now we have that. Now what I'm going to do here is I'm going to copy the entire data set. And we're going to say coded data. Copy this here. Spread it out. Make it larger. Now, referring to our code book, 123, 1 equal low, and 2 equal medium, and 3 equal high. We're going to go down here, and we're going to figure out what counts as high, what counts as medium, and what counts as low. Low, medium, and high. So 375, we're just going to equal min get our parentheses max we can get median too. So 150 is the middle set number. 150 is a medium number, which is right here. So we can say that 150, well, 25s are a low number, and 375s are a high number. So we'll code medium first. Medium is we'll say, see, there's 150. We'll say 140 through 210. High equal 211 plus, and low equal 0 through 139. Alright, so now that we have that, I believe that's all that we really need to do. Yes, it is. So we can go ahead and delete that, delete that, delete that. And now we will code. So anything under 139 is low. A lot of low counts here. Medium is a 150. And medium starts at 140 and goes to 210. And then here are our high values because they're in 300s. So poverty index, 1 through 3 is low, 4 through 6 is medium, 7 through 10 is high. So low, 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 medium, so 4, high. I have some times with my keyboard here. 7 is a high. 6 is a medium. High, medium, high, medium. Age of caretaker. Young adult is 0 to 21. Oops, undo that. And that's it. Adult is 22 through 26. and then older adult is everything else. And then our bird boys, let's say 0 through 4. Since this makes no sense, we'll say 0 through 3 is equal low, 5 through 7 equal medium, and then 8 plus is high. In other words, these are all medium. So alright, so now we have our coded data set. So now we got to perform our chi-square. So as you remember how to perform chi-square, we highlight the entire thing. Insert pivot table. Make sure you highlight the entire sheet, hit OK. Now we have our pivot tables going on, and now we get to do, our values are of course going to be in our ID. Value field settings, go to count. We got a sample size of 10, and our rows will be child abuse, and we're going to get rid of that blank, so don't worry about that. And poverty index. So here we have our very 3 category child abuse table. High, high, low, low, so far, so and so forth. So let's go ahead and copy this over. Control V, undo because it's not Control V. Paste values. And then we're going to copy this again. We're going to get rid of this because it's a little slightly confusing. Delete. Get rid of this guy right here. Delete. Get rid of this guy here. Delete. I'm just going to move this up. That up. And get rid of this. So, okay. That's a much more manageable, more looking table. I'm just going to, add my zeros. All right. And we're going to clear this out with the delete key. Equal grand total time, we're calculating chi-square. Divide by grand total. Now decimals are okay. So I'm just going to do this quick way. I'm going to show you this quick way again. And so it'll be, we want to hold our row constant, our column constant, and our grand total constant, so we can just quickly get through it. So we're going to enter dollar signs. Enter dollar sign. Enter dollar sign. At the beginning of L and at the beginning of the number. Same way over here, because we're holding red constant and we're holding purple constant. And I'll show you what happens when you don't do that too. So $I, $17. And what that's doing is it's saying, okay, so we're going to hold, in this, we're going to hold I constant, which is right here, and we're going to hold 17 constant, which means we're going to freeze this cell. If we only want to freeze a row, we just type in, freeze I, which would just freeze I. We wouldn't go down, but, that's off of that. So because we froze the row and the column and the grand total, we froze the column, my bad. We froze column and grand total. It means we can now drag, this will change and these two won't. So, we can drag it down. See? These two did not change, but that one did. Now, let's do that So equal that times this divided by that. Now look what happens if we just do it on our own. It won't work because everything went down at the same time. See how it's going down? So let's go ahead and hold our things constant again. Dollar sign, dollar sign, dollar sign, dollar sign. And then presto, it changes only that. And then we can do that again. Equal. It just saves you a lot of time in the long run to do it this way. Is that our dollar signs? Especially if you're working with very large pivot tables. You know, more than a 2x2, such as this. Alright, here is our expected and observed. Observed. Expected. And now equal pi-test. Actual range, we're going to go to observed and, you know, put that all in. Comma, expected range. We get a p-value of 0.42, which is not. And that is how you calculate. That is how you calculate your p-value. That's how you calculate your p-value for your correlations. And this is the p-value for the correlation between the relationship of poverty, child abuse, high poverty, low child abuse, low poverty. I don't know why it's organized it this way, but it is what it is. And then medium. So what it's saying here is we do not have the evidence to say that there's a high correlation in this specific data set between child abuse and poverty. And the main reason that is that we only sample 10 people, 10 places. We will need to sample more areas, or we would have to sample, you know, people. And the average age of caretakers in this area is that. So, all right. So hopefully that helps with correlations, and I'm going to pop up an assignment with correlations. And if you need any help, please contact me via email, or you can schedule a conference call or a meeting. Anything I can do to help you, let me know. And that is it for today.